Hi, so we're looking at elimination method today. Just a quick little recap, okay? So we're looking at simultaneous equations, so two lines happening at the same time. One might go like that and one might go like this. Okay, two lines that happen at the same time, and we're trying to find a solution when they equal one another, when they intersect, okay, when they equal each other. So we've looked at one method is graphing. Okay, so if you graph the two equations, then you can just look and see where the solution is. Okay, so that's probably an easier one if you're good at graphing. Number two is the substitution method. Okay, so what that one is that instead of graphing, so instead of drawing, you have your two equations. So let's just go, 2x plus y equals 5, and you might have x equals 1 plus y. Okay, so if you've got two, instead of drawing them and looking at the coordinate, what you can do is substitute. So it's kind of like making them equal to one another. Because this one says x equals this, okay, in our other equation we're going to substitute that into it. So instead of x here, we're going to write 1 plus y, and then you solve it to find the variable. So I'm just going to rub out that. This works, before I rub it out, substitution works when you have, see how x is on this side of the equation by itself and there's nothing else on that side? That's why substitution works for this one. However, when you get two equations like we do over two equations over here, okay, this one and this one, see how we don't have either of them on the same side? Okay, the x and the y are both on the same side together. So that's when we can use the elimination method. So what we need to do, we need to think of it quite literally in terms of we need to eliminate. I'll put a little thingy here. We need to eliminate one of the variables, x or y, okay? To choose which one you want to eliminate, you have to look at your two equations, okay? So the first thing you want to do, like we do with substitution, is label them. So let's go different colours. So this is our first equation, and this is our second equation, okay? Now, we want to get rid of one of them by adding or subtracting the equation from the other one, okay? So eliminate by adding or subtracting. Now, with this kind of question, you can see at the moment, if you have x minus 2x, okay, you're going to get negative x, so that doesn't get rid of it, doesn't give us 0. And even if you plussed them, so x plus 2x, you get 3x, so you're not getting rid of either of them, okay? And same if you tried for the y's. If you did minus 5 minus 3y, you're going to get minus 8y. So that's not good, okay? We want to eliminate it, so we want it to equal 0. And if you subtracted them, so plus them, minus 5 plus 3, you'd get negative 2y. So at the moment, just adding them and subtracting them like they are isn't going to work, okay? So we need to manipulate one of the equations so that that's possible. So I'm just going to get rid of this. So we're going to go, manipulate one of the equations. Okay, so what I would do here, something that kind of makes it a bit easy for me to see is that we've got an x here and a 2x here. So if we could change this one to a 2x and then subtracted 2x minus 2x, you get 0, and we have eliminated it. Okay, but you can't just add the 2 in front. To keep this whole equation the same, you need to multiply everything by 2. Okay, so if I multiply every term here by 2, you'll end up with 2x minus 10y, because 2 times negative 5 is negative 10, equals negative 17 times 2 is negative 34. Okay, so we've now got a third equation here, don't we? Okay, we're allowed to do that. So now we've got these two equations. Okay, and because we've got 2x the same, what we can do is subtract them from each other. Okay, so I'm going to say if you get your second equation, okay, and you subtract your third equation, that's going to help us. Okay, so what you can do, just get rid of these little ones. Okay, so we're subtracting this number 2 minus the third one. So the first thing is 2x minus 2x is 0, so they cancel out. Then we've got 3y minus negative 10y. So that would be 13y, whoops, equals 5 minus negative 34, okay, which would be 39. Okay, now we're solving for y, so we need to get y by itself. So if we divide both sides by 13, we'll get y by itself. 39 divided by 13 is 3. Okay, so that's good. Now to find out x, you need to sub y equals 3 into any one of those equations that you've got up here. I'm just going to say we're going to sub it into the first one, but whichever one you sub it into, it's going to be the same. Okay, so my first equation, which is x minus 5y equals negative 17, we need to sub in y equals 3. So whenever there's a y, so we've got to go x minus 5, put a 3 here, equals negative 17, and we just solve for x, so minus 15. Need a plus 15 on both sides. So x equals negative 2. Okay, so therefore our answer is negative 2, 3. Okay, so if you were to graph the two initial equations or graphs, lines on a graph, they will intersect or touch each other at negative 2, 3. So the main thing, okay, you have to eliminate one of the variables to solve for one of them, and then you can sub in the other one. To do that, you need to add or subtract the equations from each other to get rid of one of those variables. If you can't do it, if it's not that easy, you need to manipulate one of the equations by multiplying or dividing them to help you. Okay, it is a really tricky one. I'm happy to